everyone, and welcome to the sky this month. I'll show you what we can look forward to from tonight to our next Toronto Center meeting in December. This month, with early sunsets and late sunrises, we can see constellations spanning the summer, fall, and winter seasons throughout the night. Also this month, Venus, the evening star, rises higher. Comet C2023 Atlas also climbs higher. Uranus reaches opposition while Jupiter approaches its own. We get another supermoon, and the sun is as active as ever. There are also meteor showers and 3 lunar occultations coming up, so this month is excellent for Skywatch. I like to combine astronomical twilight, when planets and bright stars can be seen, with night and call it the observing window. In November, the window is almost as wide as it gets. Well, of course, it's the opposite for those in the southern hemisphere. For Toronto and similar latitudes, the observing window is almost 12 hours long as of tonight and grows 45 minutes longer by early December. Night grows from 10¾ hours to 11½. The moon is young tonight at first quarter this weekend and is full mid-month. A nice observing stretch opens on the third week in November 23, 24, and that dark stretch runs through the beginning of December. The full moon on the 15th goes by a number of names of the beaver moon, the deer rutting moon, the digging scratching moon, the freezing moon, the frost moon, and the whitefish moon. Okay, let's begin our tour of the night sky with a look at the inner solar system. From Earth's perspective tonight, Mercury lies over 20 degrees east of the sun, so it might be visible after sunset. Venus is twice as far from the sun, so it will be an easy evening star. And meanwhile, Mars is west of the sun and will rise about 4 hours after sunset. On November 15, Mercury reaches greatest easterly elongation just over 22½ degrees east. When we gather for our next meeting on December 4, Mercury will be just 2 days from inferior conjunction, when it will pass between Earth and Sun. Venus leaps to almost 44 degrees east of the sun, and it sits on almost the opposite side of the sky from Mars. The ecliptic is very shallow in fall evenings in the northern hemisphere, bringing little Mercury down with it. And look how far it sits below the ecliptic. And this puts Mercury just 6½ degrees above the horizon at sunset as of tonight. You will need an unobstructed view to the southwest to find it, and please wait for the sun to set first. When at greatest eastern elongation on the 16th, Mercury will be 7¾ degrees high at sunset. You might think greatest elongation marks the highest Mercury can get, but it will climb a bit higher. 4 evenings later, Mercury is at dichotomy, when the planet is 50% illuminated and is a little over 8 degrees high at sunset. And it's a whisker higher the next evening, its highest for this apparition. Speedy Mercury will then race towards inferior conjunction on December the 5th. Now, for observers in the southern hemisphere, you'll find Mercury sitting much higher. The ecliptic is steep on spring evenings, and Mercury's orbit is even more vertical. Now, here we see Mercury a generous 14 degrees high in the west-southwest at sunset, as seen from Chile. Throughout November, Venus is increasing in brightness and apparent diameter while climbing higher. Its set time gets later, and its illuminated percentage drops as Venus heads for greatest eastern elongation in January. Venus will be a fine target throughout the month. Now, with sufficient magnification, you can monitor its changing phases and increasing size. And that's just what Galileo did 4 centuries ago. You can do the same. Mars's movement east against the background stars slows down this month because we are catching up to it. And because we are getting closer, its magnitude gradually increases from negative 0.1 to negative 0.6, making the red dot of the planet easy to find in the eastern side of Cancer. By the beginning of December, we are heading almost directly towards Mars, and it nearly sits still in the heavens. We will begin to pass underneath Mars on December 6th, when its retrograde movement begins, and retrograde will last 81 days, with opposition happening at the midpoint on Jan 16. The apparent size of Mars increases from a meager 9.6 arcseconds to a slightly larger 12 as we orbit towards it. The planet will grow to only about 15 arcseconds when it reaches opposition in January. Now, late summer oppositions with Mars are the best. And if we're patient, not that we have any choice, there's an excellent one in September of 2035, when Mars will appear 70% larger than it will this January. On December 4, with sufficient magnification and steady seeing, you might be able to tease out some surface details and maybe the white dot of its northern ice cap. But it will be small. It will be a challenge. A little bit better in January. All 4 of the gas giants are visible at some time of the night this month. I have drawn a line here depicting the horizon for an observer at local midnight. The Earth-Uranus line is perpendicular to the horizon, meaning Uranus will reach opposition this month. Neptune and Saturn are well east of this line, having passed opposition 2 months ago, and Jupiter is west of Uranus, so it will be the last to reach opposition in early December. This month, we have a rare chance to observe all 4 of the gas giants across the meridian during the night. Jupiter shines brightly between the horns of Taurus the Bull this month. And on November 23rd, Uranus is 22 degrees west of Jupiter, or 6.5 degrees southwest of the Pleiades. Jupiter's angular size is near its maximum at nearly 48 arcseconds on Saturday, November 23rd. Since Jupiter transits the meridian around 1 a.m., that would be the best time to observe it. Any size telescope will reveal the dark zones and the bright bands of clouds encircling the planet, and the 4 Galilean moons, except any of those that might be behind Jupiter or lost in its glare when transiting in front. Here we see Jupiter at 1 a.m. on November 23rd, when Io is casting its shadow on Jupiter and is about to begin a transit. You might like to try a light blue or light green filter when observing or sketching Jupiter. These filters darken the reddish cloud bands and the great red spot, increasing contrast and helping them stand out, helping you to find them and see their details. As I mentioned, Uranus can be found 6.5 degrees southwest of the Pleiades. You can use 3 fingers at arm's length to help locate the planet's pale blue dot. Uranus is bright enough to be seen without optical aid on a dark and transparent night. Magnitude 6 is considered the dimmest we can see, and at opposition, Uranus is brighter at 5.64 or at 5.87 if you factor in the air mass dimming. But still, that's brighter than 6. You can use binoculars to confirm the location of Uranus And by magically eliminating the stars dimmer than sixth magnitude, we are left with three. Two above at magnitude 5.3, and one to the left with the same magnitude as Uranus, 5.6. Now here's that same binocular view in the red circle. You can see the two stars above and one to the left, helping to define where Uranus is. If you can see these stars, you'll be able to see Uranus. There's also a curving chain of fourth magnitude stars that you can use to help find Uranus. So give it a try now with Uranus at its brightest. Your best chance. Saturn and Neptune can be found near each other in the southwest after nightfall. And Saturn is easily found. Its magnitude 0.9 butterscotch dot is easily found in the water jug of Aquarius. Neptune needs binoculars or a telescope to find. Search about a degree above the halfway point of a line connecting Iota Ceti with Kappa Piscium. With sufficient magnification, you may detect Neptune's moon Triton, a likely captured spherical body that orbits Neptune in retrograde and has a highly inclined orbit, tilted more than 157 degrees to Neptune's equator. Saturn's rings currently appear like a line drawn through a circle, imitating a double star symbol in star atlases. The ring tilt has increased slightly to 5 degrees, up from less than 3 degrees a few months ago, but still it's on its way to zero as we pass through the ring plane 5 months from now in March. Saturn's biggest moon, Titan, is the 8th magnitude dot sharing the ring plane. You can try using light yellow or yellow-green filters to improve contrast in the cloud bands and help them stand out. Comet C2023 A3 continues to climb higher in the west this month while racing away from us on what is likely its escape from the solar system and into interstellar space. On Sunday, December the 1st, Tsuchishan Atlas passes close to open cluster NGC 6756, providing an opportunity to observe or image the pair together. And I would hope that the comet will be a bit brighter than suggested in that image. November is a busy month for meteor showers, starting with the south and north Taurids, two meteoroid streams deposited by 2P Encke. Both showers are currently active and offer around 5 meteors an hour. The south Taurids already peaked 2 nights ago or 3 nights ago, while the North Taurids will peak in 4 nights. Because the radiance of these showers rise early in the evening, you won't have to wait until late at night to see their meteors. The 2 Taurids are among the slowest of meteors, but they can produce some fireballs. Next up is the Leonids. It's a dependable shower producing around 15 meteors an hour. But this year the moon interferes, being only 2 days past full. The debris stream left from Comet 55P Tempel-Tuttle, they slam into our atmosphere at a very high 70 kilometers a second. And that can produce very bright meteors and hopefully overcome the moonlight. Of course, you have a good chance of catching some Leonids on other nights when the moon is not a problem because the shower is active all month. And the much anticipated Geminids, with a generous zenith hourly rate of 150, they start to become active on November the 19th and remain active up till December 24. The peak won't happen until mid-December when the moon again is a nuisance, but bright, colorful meteors may streak across your night sky in the second half of November, when the moon is out of the way. This shower is unusual in that the debris was left behind by an asteroid 3200 Phaethon, whose orbit crosses Earth's and is considered a potential threat. Phaethon is not an icy body like most comets, like comets are. Instead, its water has combined with other molecules to form phyllosilicate and carbonate materials. Now, when heated to 800 degrees Celsius by the sun, the carbonates release carbon dioxide, while the phyllosilicate give off water vapors, and sulfides in the asteroid will release sulfur gas. These gases exert pressure on the rocky material, cracking it up, producing some small pieces and dust particles that the gases will lift off from the asteroid. Onto the sun. The sun at local noon drops by 5.8 degrees over the next 4 weeks. Meanwhile, Earth is nearing its perihelion with the sun. That occurs in early January. The sun has been extremely active for many months now. Active region 3872 that produced an X1.8 solar flare back on October the 26th, it has now rotated out of view. Meanwhile, a new pair of very active regions, 3883 and 3886, are rotating our way. These regions have been giving off M-class flares the past few days. In fact, I read today that 3883 gave off an X3 or X4 level flare, but it was very brief, so it probably didn't eject very much solar matter into the towards us. However, it's an indication of how busy those regions are. 3883 has been giving off multiple M-class flares daily as it rotates to Earth-facing. Its sunspot count has dropped a little from 30 to 22, but the overall size of the region continues to grow since it was first seen rounding the western limb. Its beta gamma delta magnetic classification is the most promising for producing X-class flares with coronal mass ejections, or CMEs, that can produce auroral displays at mid-latitudes or lower. The delta in that classification indicates that there is at least one, or probably more, spots within it that have opposite polarities inside the same penumbra. That's sure to create sparks. Currently, 3883 has a significant 30% chance of having X-class flares and a strong likelihood of more M-class activity. And both X-class and M-class flares can produce CMEs if they are powerful enough and if they last a long time, because that gives a greater chance for the plasma to lift off. And C-class flares they're as half as intense as the M-class and are unlikely to have any effect on Earth. Here's an M3 flare from the region 3 days ago, while not aimed directly at us. It included some plasma ejection that might have given Earth a glancing blow, but I didn't hear about any auroras, so I think it missed us. 3886 shows signs of developing into a fierce beta gamma delta region like 3883 is. Its sunspot count and size are both growing. It's a beta gamma region now. That is spots of positive and negative polarity mixing it up. If delta spots develop, those are the ones with the two polarities inside the same penumbra, it can also produce mid-latitude auroras like 3883. 3 weeks ago, NASA and the NOAA announced that the solar maximum has already begun and suggested that it may have started as early as 2 years ago, long before initial solar cycle forecasts had predicted. The scientists also noted that solar activity will likely remain high for around another year. That's great. This chart shows the average sunspot count in July matching a high last seen 23 years ago in September through December of cycle 23. Since then, the average monthly count has grown, reaching 215 in August, according to the Royal Observatory in Belgium. Some of you may have seen the auroras back in May. They were the result of waves of CMEs, one behind the other, that piled into the Earth and produced a G5 level geomagnetic storm. That's equivalent to the one that triggered the Carrington event of 1859 that caused sparking and even fires in telegraph stations and auroras seen at the equator. Luckily, there were only minor power grid disruptions this time. I guess we lucked out. Maybe the largest pulses occurred over the oceans. The auroral display many of us saw in October was a G4 storm, nearly as strong. So cycle 25 has already matched activity levels from cycle 23 and is still growing. So the prospects of more auroras are good for this month, this winter, and maybe another year. Okay, on to the moon now. It reaches first quarter this Saturday, November the 9th. Then see how it migrates closer towards us, reaching perigee on Thursday, November 14. Full moon is the very next night. Since new moon happens just a day after perigee, it's well within the criteria of appearing at least 90% the size at perigee, and hence we can call it a supermoon, and it's the final of 4 consecutive supermoons we've seen since August. 1 week later, as the moon is receding from us, it will reach last quarter when its angular size is exactly half a degree. The moon reaches apogee on the 26th, is new on Sunday, December the 1st, and will be a slender waxing crescent the night we gather for our next meeting. On Monday, November 18, when the moon is gibbous, there is an opportunity to explore a pair of craters featured in the Explore the Moon observing program. Atlas and Hercules are 2 prominent craters in the moon's northeast quadrant, and they will be near the terminator as sunset approaches. Atlas is the larger and older of the 2. It has a sharp rim resulting from a slumped terraced wall, an uplifted tortured floor with low hills in the center. In contrast, somewhat smaller Hercules is deeper, has broad walls with multiple terraces and a lava-filled floor. A prominent crater south of its center will be filled with shadow as the sun is drifting lower. See if you can find its dark spot in the floor of Hercules. Like maybe that's it there. And it's now time for close encounters of the lunar kind. This month the moon gets real close to Neptune, the Pleiades, and Spica, so close it actually occults them. On Monday, November 11, around 9:10 p.m. in Toronto, the unlit limb of the moon passes in front of Neptune. This animation is running at normal speed, and you'll notice that it takes 6 to 8 seconds for the limb to totally cover up Neptune. There's the very faint dot right there, and it will soon be covered entirely by the moon's limb. So in other words, Neptune will disappear gradually. The exact timing for you depends on your location. For example, in Hamilton, slightly west of Toronto, it happens a minute earlier. Out east in Halifax, you'll need to wait until 10:30-ish local time. and it'll occur around 8 p.m. in Winnipeg and 8:09 local time in Saskatoon. Observers in Alberta and BC will see the moon skim just south of Neptune. The full moon on the night of Friday, November 15 to 16, will glide through the Pleiades, visible across North and Central America. Because of the glare of a full moon, you will need to use a telescope to see the brightest of the stars as they are occulted and as they re-emerge on the other side. A moon filter may help. A very attractive occultation occurs in the pre-dawn hours of November 27, as seen from Toronto, when the sunlit limb of an old crescent moon slips across Spica. A little over an hour later, Spica pops back into view from behind the dark limb, which will be softly lit by Earthshine. So this side of the moon will be visible as the star reappears, lending a 3D feel to the view. Observers in parts of central US and Canada can watch the occultation in darkness, while further west it occurs during or maybe before moonrise. You can use an app like Stellarium to see if or when the occultation can be seen where you are. To round out tonight's look at the sky, I'd like to mention 3 deep space objects that lie high in the sky where there is less air mass to diminish their brightness and detail. The moon doesn't rise until after midnight in the 3rd weekend of November, so I've chosen that weekend for illustration. And first up is NGC 40, the Bowtie Nebula that climbs higher than 60 degrees in altitude, where you look through only 1.16 air masses. You can find the planetary nebula 5.5 degrees southeast of Gamma Cephei. The nebula is composed of hot gas surrounding the remaining central core of the star that heats up the gas to 10,000 degrees Celsius, causing it to emit red light. The shape of the gas is cylindrical with bright patches on the sides of the barrel, where, from our perspective, the gas is concentrated and there is more light there, and that's where it appears the brightest. And that gives the nebula the Bowtie nickname. Next up is M110, the final entry in the Charles Messier catalog of things that aren't comets. Although Messier saw and described the object in his notes, he never added it to his catalog. Instead, it was added posthumously in 1967 by Kenneth Glyn Jones, who was an astronomy historian from Wales and a fellow of the Royal Astronomical Society. M110, like neighboring M32, they are dwarfed galaxies that orbit M31, the Great Andromeda Galaxy. This trio of galaxies drifts very close to the meridian in November, making this a prime time to observe them. Now, you can find the galaxy north of Merak, the star marking the hip of Andromeda, the princess. What I like to do is connect Merak with the 3 dimmer stars above it to make Arnie's champagne glass. The fizzy champagne in the glass forms a cloud above it, the smudges of M31, 32, and 110. Dwarfed galaxies typically have their star-forming gas and dust stripped away by the large galaxies they orbit, leaving them with only old dying stars. But M110 is designated as peculiar because it still retains patches of dust and young blue stars near its center, resulting in a concentration of brightness in the middle of its elliptical shape. Our final deep space suggestion is Messier 34, coined the spiral cluster by Jeff Bondono from what he perceived to be a spiral of stars in its makeup. The cluster comes very close to the zenith around 11 p.m. on November 23rd. You can easily find the cluster in binoculars by scanning 1 degree above and slightly to the left of the halfway point between Algol and Almach. M34 is 1,400 light years away and estimated to be 200 to 250 million years old. It is over half a degree wide, and in telescopes, it is best observed under lower power. Under a transparent dark sky, it can be detected by eye alone. Up to 80 of its estimated 100 stars can be resolved in a good telescope. And if you have any questions, please feel free to submit them to our forum, and I will be happy to answer them. Hope you enjoy the sky in November. Have a great November. Good night.